Come light it up, I'm ready to go. Come light it up, come light it up, I'm ready to go. Come light it up.
Welcome everyone to Datanova 2024. I am so excited to present to you my latest research. It is called Is Trino the PostgreSQL of Analytics? Why did I decide to pick this name of PostgreSQL in the title? I have been a data and analytics analyst for a very long time. And if any of you have ever gone or embarked on a journey to evaluate the right database for your organization, you may have come across sites like DB Engines. This is a site that chronicles over 300 active databases. But the one that is rising the fastest and the one that is the most commonly cited in all kinds of publications is PostgreSQL. So why PostgreSQL? What is the need to have 299 more databases if PostgreSQL is it? Well, I'm glad you asked that question. The reason is because our data estate is very complicated, and data is a victim of its own success. We have more users, more use cases, more workloads, more data sources, and because of that, we need all kinds of processing engines. Some are specialized for certain niche areas, and some are more general purpose. So Postgres has become, in the operational database world, it has become the de facto standard when you are looking for a flexible, versatile database that meets most of your needs, but not for specialized use cases. So today, what we are going to do is we're going to talk about the key requirements of analytical systems. We will then see, does Trino fit those requirements? So we look at both strengths and weaknesses. This is not just a one-sided discussion that we're going to have. So let's start with some introductions. My name is Sanjeev Mohan. For many years, I used to be a Gartner analyst. I directed the research agenda for data and analytics team. And then 3 years ago, I decided to start my own advisory firm called Sanjmo. Sorry, no points for guessing where that name comes from. In my copious free time, I have managed to author a book called Data Products for Dummies. I write prolifically on Medium, where I publish my blogs. I also record podcasts on my YouTube platform called It Depends. I would love for you to subscribe, follow, if you find value in the content I produce. So with that, let's get quickly onto the agenda. So I want to talk about what are some of the trends and some of the hot topics and why analytics is in such a flux, if I may. So we look at that. We've talked about PostgreSQL. We will look at what is Trino, and then the most important thing that we will spend our time on today are the trends or the tenets of a modern analytics environment, and how do you pick the right tool. Please add your questions to the platform, and we will answer your questions as quickly as we can. So with that, let's get started. And I want to talk about what are the businesses looking for. I'm a techie. I can talk all day about technology. Businesses don't really care. Businesses only have a few requirements. They want access to the data when and as they need it. So they want to be able to make decisions on probably the freshest data they can get their hands on, but high quality data that comes from many, many different data sources. They don't want to be writing separate queries for different data sources in different languages. And while they are asking for a trusted access to their data spread across different silos, they also want to make sure that we do not break any regulatory compliances. So personal data needs to be protected. We need to have an understanding of where this data is coming from and who is allowed to see it. So only the right authorized people should be allowed to see the data that we are querying. That is what the business needs. Now, all that is great, but we also have to keep in mind that there are a lot of market pressures that we have to deal with. We are living in times of economic headwinds, which means that the IT spending has reduced, not in every aspect. A lot of organizations are migrating to the cloud, so the cloud spend goes up quite a bit. But then AI has now taken over all our discussions. In fact, you'll be happy to hear that we do not talk a lot about AI in this session, which is quite a change from a lot of talks these days. But the fact is that to pay for AI, especially generative AI, that money needs to come from existing budgets, and those budgets are already under pressure. On top of that, the complexity of the tech stack has gone up tremendously. And that's because of some of the things I said earlier, because now we've got more data sources and more workloads. So we are doing all kinds of analysis on our data. And as a result, we are having a bit of a challenge finding talent for these very specialized point solutions. And to make the matters worse, AI is also causing a lot of disruption in this market. The final thing is that I talked about regulatory compliances. Regulatory compliances somehow were the forte of European countries because they were at the forefront. But now we see regulatory compliances have spread to pretty much all over the world. A lot of Asian countries do not want data that is specific to their country and their citizens to leave the boundaries. So that means that data governance has moved from being an afterthought into being part and parcel of our analytical stack. So what does all this mean? This means that there are a number of trends causing us to rethink our analytics space. Now, I've listed three. Of course, there could be many more. So the very first one is user experience. Now, users are happy when they get the data in a timely fashion. So to some extent, a lot of user experience comes from how interactive my analytical engine is. Also, how much effort does it take for me to start using it? Like the time to onboard users is highly critical. If in light of all the economic market pressures I talked about, when we hire new people, we want them to be productive as quickly as possible. So open standards become really important, like SQL. Ability to use a language that most people have used in their schools and other places of work becomes really important. Also, open standards help us in reducing complexity because our stack is changing very quickly. So we don't want to be in a situation where we get locked into a certain stack. So that leads us to the main topic of today, which is to talk about what are the key requirements or the tenets of a modern analytical engine. Now, here I do want to point out that it's really this is how some of us in the analyst world work. We like to create these evaluation criteria because then it gives us a solid foundation to look at the pros and cons of what we are evaluating. So like I said, the way we are going to do this section of today's session is that we will look at what are the generic requirements in each of these categories, and I'll go in a clockwise fashion. And then we will look at what is Trino's applicability to that. So I'm going to start with use cases. Now, you may ask me, okay, why are you starting with use case? Well, another excellent question. I'm glad you asked. That's because I can talk all day about how highly performant, scalable a system is, and guess what? It's open source. But if I don't meet my business requirements, then what is the point? The business is not going to adopt that tool. So that's why it's really important to look at use cases. I have laid out the use cases in left to right linear fashion of how we build our analytics stack. So if I start from the left hand side where my data originates, that those are my operational systems or my transactional systems. I'm going to extract that data. So there's some data engine ingestion that is going to happen into my analytical engine. I transform that data and then I start doing queries. So so that is the process. Now let's look at what are the strengths and weaknesses of Trino in this case. Before we look at what, it is really important to understand the why of anything that we are going to look at. Why Trino? Why the need to create a new analytical engine? The story of Trino goes back to 2012 when Facebook, now called Meta, was running out of steam trying to analyze their hugely and quickly growing volumes of data using Apache Hive. A number of people at Meta at that point in time decided to create a new way of analyzing data that was distributed. It was massively parallel processing by running multiple engines. They were able to get the kind of interactive volume on ever growing pieces of data. They called that engine Presto. In 2019, some of these creators left Meta, but they continued developing the analytical engine further, but this time they called it PrestoSQL. PrestoSQL and Presto are very similar in name, so in order to not cause any confusion, they renamed PrestoSQL to Trino. So Trino, now that you know the history of Trino, so you know that it was built for the number 3 and 4, which is for ad hoc interactive queries and for either real-time or batch streaming. But the reason I mentioned this history is because I'm talking about ingestion, I'm talking about ETL, ELT, and data federation, that those were not the original use cases for which Trino was created. Over the years, as Trino has matured, they have now added more capabilities that allow you to do continuous queries. But Trino is not your real-time stream processing engine like Apache Flink is. Also, it's important to note that if you want millisecond access, then there are other options like Pino or Druid, Startree. There are a number of products that provide you with that real-time access. So Trino is more for near real-time. Now, when it comes to ETL and ELT, now this is yet another expansion of how Trino is being used. Trino now has these built-in SQL functions. These SQL functions allow you to filter data, do aggregations. Because Trino is an extensible software, you can even create your own user-defined functions if you do not find that built-in SQL functions meet your requirements. Also, Trino has the concept of connectors. So they connect to a number of not just data sources, but even other ETL processing engines. One very common ETL processing engine is dbt. So there's a dbt connector. You could write your SQL and you could use dbt connector and you can pull the transformations out of dbt and you can do your analytics on that. Now, talking about connectors, I also want to mention that that the connectors connect you to data sources where a lot of which may be your system of record or your single source of truth for certain pieces of data. A few minutes ago, I talked about how so many countries are restricting movement of data outside their realm. So that means that for certain use cases, if my data is spread across different data sources, I want my query engine to be able to connect to multiple data sources and join them while my query is taking place. That is a concept of data federation. So that is how you have the ability to not only move everything into a single place, i.e., a data lake or a lake house, but also query data in its original source by doing query federation. This query federation could be I have my historical data in my lakehouse, but my most current data is in, let's say, a document database, JSON or BSON based MongoDB. How can I connect it on the fly? Interestingly, a lot of federation requires you to have some sort of a semantic layer. So in case of Trino, now they have connectors to AtScale, Cube.js, and other semantic layer providers. So you can also benefit from a semantic layer, a universal semantic layer, if I may. The last use case I want to talk to you about here is AI and ML. And in this space, there are a lot of things that we do. We prepare the data, we do feature engineering, we get our data ready for do machine learning model training. So Trino use cases are now being expanded by the organizations to accomplish AI and ML use cases as well. So let's move on to the next topic. The next topic is performance and scalability. This is one of my favorite spaces, and the reason why I say I like this space a lot is because as we have moved more and more of our workloads into the cloud, the performance aspects equal the cost. So in the cloud, you pay for consumption or you pay for resources as you use them, as opposed to in my past when we were on premises, it was a sunk cost, it was a capital expenditure. You paid for it once and for all. It did not matter how and when you used your software, the cost was not associated with usage. So the first thing that I want my analytical engine is to have an intelligent query planning uh, optimizer that can help build the most cost effective way to query my data. The second thing is I want that to be highly distributed across many different nodes. High concurrency. As the number of users increase, I don't want to pay the penalty for performance degradation. So this is where scalability comes in. In fact, the topic of scalability is a very nuanced topic because we think scalability is as the volume increases, but it's not just the volume, it's also the number of users that we need to be able to scale with. We want to be able to maintain the query performance through in-memory queries. We want the scalability to be enabled either horizontally or vertically. Horizontally, the way we do it is we add more nodes as the need goes up. So we scale out, and when the need when the peak is over, then we should hopefully be able to scale in. At the database level, we make copies of data across. When we scale out, what we call shards, when we go up to the analytical engine, we need an ability to distribute our query processing across these new nodes. The way Trino works is there is a coordinator node that does the query planning, and then it spawns off these worker nodes. And the worker nodes will increase in size as the demand increases to provide me with a constant SLA for my query response time. The other thing that I also want from my analytical engine is that when the coordinator node does the scale out. By the way, scale up. Let me complete the vertical story. The vertical scaling is when I have a single node query engine, and as I need more resources, I keep adding more memory or more processing power to a single node, and I scale to a larger node, not multiple nodes. So we should have the ability to support both. Now, I was talking about query planning. How query planner's job is to also uh, uh, be able to use heuristics and be able to predict when would I need to scale out. Like, for example, I may know that at the end of the month, I need to run my monthly closing of my books. And if I have that history, then the query planner should be able uh, to scale out. So there are a number of other things that we talk about as we proceed. So the next big thing that I want to talk to you about is open source and open standards. Why is this important? Is because of some of the things that we talked about. For example, we talked about not being locked in, have the ability to migrate to something new that comes up down the road, which happens all the time these days. The velocity of change in our space is unprecedented. So with open standards, I'm not locked in. I can move, migrate from one system to another system. Open source are mostly prevalent in the data infrastructure. As we move up, we see at the lowest level, uh, even at the operating system level, Linux is now the most prominent operating system. But when we go up, the most common file format for analytics is Parquet. The most common table format for analytics is Apache Iceberg. And if we move up to the SQL engine layer, then that's where you would find Trino. But also for stream ingestion, we've got Spark, we've got Flink, we've got Kafka, and that's how prominent these open source and open standard have become. A lot of times we have to be a little bit careful because there are many different types of licensing, and we see this happen sometimes where a product may be open source one day, and then some organization decides to make it proprietary, and then they have very restrictive licenses, and the costs go up. So having this true open source, in case of Trino, there's a Trino Software Foundation that is responsible for ensuring that it stays open source. The next thing is community support and updates. What do I mean by that? I run into a lot of vendors in the community who tell me, "Oh, look at the number of GitHub stars we have." That's great. You have so many GitHub stars, but it's not as important as understanding how engaging and vibrant your community is, because it is a community that is going to drive the innovation, the development, provide the support to that open source product. So having that engaging community is really important. So Trino, as we've talked about, similar to Postgres, has that community, and we see so many new features that are being added. In fact, one of the features I will talk about is called fault-tolerant execution modes, but I'll hold on to my enthusiasm about this feature till we get to the right spot. So let's move on to user experience and ecosystem. In some ways, we've already talked quite a bit about this. I mentioned earlier on that one of the best indicators of user experience is how quickly am I able to get the results that I'm requesting. So my ability to use a language that I know, i.e. SQL, and get interactive response becomes a very important part. Also, sometimes I may want to embed uh, my query engine into something that I'm used to for doing my analytics. For example, I may be using Tableau or Power BI or Looker at work, and so the ability to be able to use Trino without having to do any custom development becomes really important. And then having a vast number of connectors. I talked about DBT, but connectors into I also talked about MongoDB, into various multitudes of products that make up my data ecosystem is really important. Now that takes us to reliability and deployment. So now I can talk about fault tolerant execution mode. Remember, I talked to you in the use cases about the ability or the extension of Trino to now support ETL and ELT or data transformation workloads. These are long running workloads. You know what happens when you have a long running any query or any workload or pipeline or a DAG. If something can go wrong, it will go wrong. Nodes fail all the time. So now what happens if in a long running job something fails or there's some unexpected behavior and anomaly? So Trino has addressed this recently by by this fault tolerant execution mode, where what they're doing is that as we process the data, there's a lot of temporary intermediate data that's created. So they're spooling that data to a different worker node. And we talked about coordinators and workers. So now I can checkpoint my jobs. I can spool the work to a different worker node. If for some reason one of my worker nodes were to fail, then I can fail over to the other worker node and I can auto restart without having to manually figure out. Because the worst thing that can happen is I run a job at night, I come to work in the morning and I see it has failed and now I'm behind. So this ability to auto restart becomes a very important part of having a reliable analytical engine. The other part I'm talking about here is deployment. I want to have the ability to either self-manage it for whatever reason, like mostly for three reasons why people want private cloud self-managed. One is, of course, compliance, security. The second is sometimes you may get better performance by having it in your own environment rather than going to the cloud. And then the third reason is cost. You may already have a lot of infrastructure where you want to run it in-house. So having this ability to be able to deploy my analytical solution in the cloud, on premises, on the edge, private cloud, public cloud, all of that is a very important requirement. We also see that there's a big requirement for modern processing engines to be serverless. So you pay as you go. That was one of the bullets we saw in performance and scalability, and it brings up the engine as I need it. When I don't need it, then it reduces the need to keep that running. A lot of cloud cost, as much as 30%, is actually wasted because we over provision infrastructure. And then there's this thing called BYOC, which is bring your own cloud. And that bring your own cloud basically means you're bringing the analytical engine to where your data is. And if your data for security reasons is in your private VPC, then I want the engine to work where my data is. I may not want to put it into the public cloud. So one of the ways Trino also addresses deployment is that it is available as a container. It's orchestrated using Kubernetes, and that makes it, again, adhere to open standards and makes it very easy to deploy. So that takes us to security and governance. And once again, we've talked quite a bit about it. Security and governance could be a whole topic by itself because it is so critical. And it has so many multiple parts. Authentication of users, authorization of users, who is allowed to see what? That is data access control. Is the data encrypted? But is it encrypted on at rest or in motion. So I need my analytical engine to be able to support all kinds of encryption so I can meet regulatory compliance. The most common one being the EU GDPR, but GDPR came into effect in May 2018. So it's been many years now that we've had GDPR. Since then, it has spread to like California has CCPA and some derivatives, and most of the world now has these compliance regulations. I also want my I want to have an ability to see where did data originate, how was it transformed, who transformed it, and how is it being consumed by the end user. I get that through lineage. Within lineage, I also need to be able to audit, log actions that were taken. So in case there is some reason why that makes me go back to investigate what happened. I have logs and I can audit, and all of this, by the way, that I'm talking about, this is all metadata about the data sets that we are analyzing, metadata about the users and their usage, and we need an ability to do metadata management. The most common tool that is used for that is a data catalog. So Trino has built in a lot of these security and governance features. It also has connectors to third-party products that specialize in some of these aspects that we talked about. That takes us to the Q&A section. Thank you so much for adding your questions as we were going through this session. Really appreciate your attention and looking forward to working together. Thank you so much.